Hello everyone, welcome to Next Generation Science Standards 101. This is part 3, titled Uncovering the Cross-Cutting Concepts. My name is Kirk Robbins, and I am a science education consultant in the Puget Sound region of Washington State. On the screen you can see the URL to my science education resources blog, and if you want to follow me on Twitter, you have that also. This is the third in a series of online professional development modules to become familiar with the three dimensions of the next generation science standards. As with the other modules, these are intended for any K-12 teacher in Washington State and specifically for the districts on the screen, but we're more than happy to have any folks from other districts or from other states who want to learn about the next generation science standards. We want to provide acknowledgement to Washington State Laser for funding the South Sound Laser Alliance, who made these online modules possible. Also want to thank the regional science coordinators in Washington State, and you can see the link to the URL there if you want to reach out to your local science coordinator. Many of the resources that were used in these modules came from science coordinators, from regional districts, and others are just things that I've put together in the last couple of years. There are a few things you'll want to do to get ready for this online session. First is to find a partner. These online modules are really designed to be used by at least 2 people or a small group in a learning community. Please do engage with the tasks. So if I ask you to watch a different video link or to read a piece of text, please do that. You'll get a lot more out of the session. Please download the documents. You may want to do that ahead of time. And it's possible that your district may have asked you to use the Google form, in which case you'll find the Google form link off to the right side of the video, and that's just a place where you can enter some of your feedback and debriefs as we go through the module. You want to set aside about 60 minutes. The video itself won't take 60 minutes, but to do all of the tasks, it should take about an hour. And be prepared to pause the video and stop and do some reflecting with your partner or your small group. Our agenda for this online session is to learn about another part of the next generation science standards called the Crosscutting Concepts. And you'll notice there will be lots of green in the background and on the slides, because in the next generation science standards, the cross-cutting concepts tend to be shown in green. So some things that we're going to learn about first is just what are the cross-cutting concepts. Once we have a sense of what those 7 cross-cutting concepts are, we're going to do a few different activities to deepen our understanding. One is we're going to watch a video about a short case of something that happened in science and see if we can identify the cross-cutting concepts in that video. Then I'm going to show you an interesting phenomena about a system, and you're going to come up with some questions about that system. We'll do some reading about the cross-cutting concepts, and you'll do some thinking about the reading, and then we'll watch a video. This is going to be a little different type of video. It's not students learning in a classroom, but it's actually teachers doing some professional learning about the cross-cutting concepts, and we'll do some thinking about what we would like to remember or what we appreciate about that video. In the last online module, if you've been going through them in order, we learned about the science and engineering practices, and the science and engineering practices are the part that's usually in blue in the next generation science standards, and you can see the 8 practices on the screen. So we learned a little bit about those. We watched the video case about sea-star wasting syndrome and thought about where the practices might be being used in the video. We read the article about climate departure from the New York Times and thought about how the scientists and engineers in that story may have been using the science and engineering practices. And then we finished with a 3rd grade classroom, the video where they're thinking about, do very tiny things have weight? And we thought about which of the science and engineering practices the 3rd graders were doing. So tonight we're gonna step away from the science and engineering practices and really be thinking about the 7 cross-cutting concepts. This is a slide that I think we've put in each of the sessions so far, and the title is What's Different About NGSS? And what we've talked about is the big innovation in the next generation science standards is the integration of the three dimensions, or what we call three-dimensional learning. So far we've learned about one of those dimensions, the science and engineering practices, and today we're going to add another dimension, the cross-cutting concepts. So in the next generation science standards, the performance expectations integrate those three things together, and we've never had standards like that. Usually we'll have standards separately about each of those things. So this is going to be a big shift to have students engaging in all three of these dimensions at once. So this session is really designed for us to just zoom in on those cross-cutting concepts so that we can think about how to be intentional with them with our students. On the screen, these are the 7 cross-cutting concepts. And just like I said with the science and engineering practices, it's the same set of cross-cutting concepts from kindergarten up to a senior in high school. Now, those students might use those cross-cutting concepts differently. They probably will, but it's the same 7. So first we have patterns. If you're an elementary teacher especially, you're probably teaching patterns in other content areas such as math, right? So it's nice to have that connection with science. Cross-cutting concept number 2 is cause and effect. So again, for elementary teachers, you're probably using cause and effect when you're teaching literacy. So cause and effect is huge in science and engineering also. 3, scale, proportion, and quantity, which is also a mathematics idea. Number 4, systems and systems models, and I underline that just to draw our attention that in Washington State, we've actually had a focus on systems in our last 2 sets of state standards, so systems shouldn't be a brand new thing for us. Number 5 is energy and matter, and I bolded energy and matter because in the past we've thought of energy and matter as content, as in a disciplinary core idea. So energy and matter is a disciplinary core idea in the next generation science standards, but it's also a cross-cutting concept. So the idea that energy and matter flow through living systems, earth-space systems, and physical systems. Number 6 is structure and function. And number 7, stability and change. So the idea of the cross-cutting concepts, what makes them cross-cutting is that they're cutting across the 4 domains, life science, physical science, earth space science, and engineering and technology. One quick note before we move forward is that most of the cross-cutting concepts aren't actually new. You can see here that in our old National Science Education Standards from the 90s, they had something called Unifying Concepts and Process Standards. And many of those ideas are the same as the cross-cutting concepts. Some of them ended up in the practices. And then in Project 2061, they talked about common themes, things like systems, constancy, and change, and scale. So the cross-cutting concepts really aren't brand new ideas. What's new is that we're actually going to teach and assess these and not just marginalize them like we've tended to do in the past. In the very first online session, I had you download what I called a cheat sheet, and it was just kind of a bookmark style document where you could see the science and engineering practices, the disciplinary core ideas, and the cross-cutting concepts. There's a cheat sheet level 2 that you'll see a link to over on the right, and if you would download that and kind of skim over it quickly and really focus your attention on the green section, which is the cross-cutting concepts, what's nice about this document is that it gives a little more detail for each of the science and engineering practices and cross-cutting concepts, more than just the title. So take a second to skim over that. Now that you've had a couple minutes to skim over what the 7 cross-cutting concepts are about, we're going to watch a video. This is one of my favorite videos. It's called How Wolves Change Rivers, and it is the story of the reintroduction of wolves into Yellowstone National Park after they had been absent for, I think, 7 decades or so. So it really tells the story of what happened when these wolves were reintroduced. What I want you to do is, as you're watching the video, turn to page 2 in your notebook, and you'll see on page 2 that there it lists all of the cross-cutting concepts, and then there are 3 columns that will go through the activities we're going to do in this section. And the first column is to take some notes from How Wolves Change Rivers. So you're just looking for, is there any evidence of the different cross-cutting concepts being at play in the story of how wolves changed rivers. So after watching the video, How Wolves Change Rivers, make sure and take a couple minutes to debrief with your elbow partner or with your small group and jot down some of your thinking. So what I have on the screen, I've used this video in face-to-face professional development many times, so I just wanted to share a few observations that some folks have made. This is by no way considered the right answers or anything like that. These are just some things that people have said. So for example, where might patterns be present in the video How Wolves Change Rivers? Some people have talked about the pattern of the deer, the behavior of the deer, and how that pattern changed once the wolves were on the scene. Cause and effect, most people will say, yeah, cause and effect is very overtly present in the video, and that the whole story is just kind of this cascade of cause and effect relationships. For scale, proportion, and quantity, sometimes that can be a trickier one for us to identify in the video. Some people have talked about kind of a proportion or scale idea, that it was a small number of wolves that had this huge effect on the system, which leads us to systems and systems models. This is another one where many folks will say that there's a very clear theme about systems and the connections between all these different living and non-living parts of the system. Energy and matter. This tends to be, depending on the grade level I'm working with, sometimes people don't initially see that this really is an energy and matter story, that anytime that you have food web and relationships like that in an ecosystem, that really is a story of the flow of energy and matter in a system. Structure and function. This one sometimes feels like we're pushing a little bit to find it, but people have talked about how the wolves led to a change in the actual structure of this ecosystem, which led to changes in the river. And that ties nicely with stability and change. So there was a stable system before the wolves were there, and then the wolves were reintroduced. There was a change, and then a new stability was created. So those are just some examples of some things that you might have talked about with your group or with your partner, but you probably had lots of other great connections. The idea of this activity isn't to be right or to be wrong, but really just to be thinking about something real, the video case, and then applying the cross-cutting concepts to that. So for us to keep thinking about the cross-cutting concepts, we're going to switch away from wolves and we're going to talk about something different. One of my favorite little systems, something called a hand bubbler, and some of you have probably seen these hand bubblers before. It's just a very fragile glass system that has a colorful liquid inside, and when you hold on to the hand bubbler, something interesting happens. So what you're going to do in a second is you're going to watch, I made a little video just using my phone, so it's not the most amazing high-def video in the world, but you're going to watch this video of me testing a hand bubbler, because I can't just reach through my computer and hand you a hand bubbler. That would be pretty sweet if I could. So you're going to watch the video of me using a hand bubbler, and then what I want you to think about is, so if we were going to use the hand bubbler with some students, which we're not, but if we're just pretending that we were, see if you can come up with a question for each of the cross-cutting concepts that would draw students' attention to that cross-cutting concept. So for example, what might be a question that we could ask about patterns that relates to the hand bubbler? What might be a question about cause and effect that relates to the hand bubbler? And you'll want to do that on page 2 in your notebook. So watch the hand bubbler video and then spend a few minutes with page 2 jotting down some questions about the cross-cutting concepts.
Hi everybody, I have an interesting device that I want us to look at in order to think about the cross-cutting concepts. This is something called a hand bubbler or a hand boiler, and I have 2 of them here. We're going to take a look at this one that has a red liquid inside. So these are made of glass, very fragile. You can see there's a bulb at the top, a bulb at the bottom, a glass tube that connects the 2 bulbs together, and there's a glass rod that goes way down almost to the bottom of the bottom bulb, and this one has some kind of a red liquid inside. So what's interesting, when you hold on to the hand bubbler, the liquid starts to rise. It's going kind of slow. So that happens. And that was me holding the bottom bulb. Then if you hold on to the top bulb, the liquid seems to go back down. So one thing I want you to think about is if we were going to have students use a system like this hand bubbler, what might be some questions that we would ask them that relate to the cross-cutting concepts? So you're going to try to come up with a question for each of the cross-cutting concepts that has to do with the hand bubbler. Let me show you something else. So I have some ice here. If I grab some ice and put some ice on the top bulb, you can see that that draws the liquid up, also having ice on the top. So now let me get some ice in my hand again and put some ice at the bottom, and that draws the liquid down. Wow, that was really quick, right? So we had heat at the bottom, drove the liquid up, cold at the top, also drove the liquid up. So I want you to think, what might be some questions about the cross-cutting concepts that we could ask kids about the hand bubbler system?
So hopefully you've taken a few minutes to think about the hand bubbler, to watch the video that I uploaded, and then to think about some questions that might relate to the different cross-cutting concepts. So this is also an activity that I've done many times face-to-face in workshops with teachers. So I just put together a table of some examples of questions. Again, by no sense of the imagination are these the right questions. These are just some quick examples for us to talk about. I've had loads and loads of different questions for each category. So an example of a pattern question might be, what patterns do you notice in where to hold the hand bubbler to cause the liquid to move? And then there'd probably be lots of other patterns questions you could ask too, right? A cause and effect question might be, what is causing the liquid to move? And you'll notice that's probably the big driving question for the hand bubbler, is what the heck is causing this to happen? A scale, proportion, and quantity question might be, would a larger hand bubbler work the same way? And you'll notice that many of these questions could fall into multiple categories, and that's fine, right? That's teaching us something about the cross-cutting concepts. What parts of the system would we want to include in order to explain how the system works? That could be a type of a systems or systems models question. An energy and matter question might be something about, how might our understanding of energy transfers help us to explain how the system works? So asking kids to use something that they might understand, like energy transfers, to explain the system. A structure and function question could be something like, what do you notice about the structure of the glass tube in the bottom bulb? There's something about the tube in the bottom bulb there's something about that structure that's very particular, right? And then a stability and change question could be something like, what changes in the system when you add heat from your hands? So again, a lot of these tie back to cause and effect. Many of them are systems types of questions, but hopefully that gives you a little more of a sense of what those cross-cutting concepts are about and how we might start to generate some questions to help learners think about those cross-cutting concepts in terms of the phenomena that they're studying in their science. So far we've watched the How Wolves Change Rivers video, thought a bit about the cross-cutting concepts there, did some thinking about a hand bubbler, tried to come up with some questions about cross-cutting concepts. Now we're going to do a little bit of reading. In the next generation science standards, there are several of these very thoughtful appendices to help us out. And what we're going to do is look at one of these appendices. It's Appendix G, which is on the cross-cutting concepts. What you're going to do is, depending on the size of your group, if you've got a big enough group, you could jigsaw this so that one person read each of the 7 cross-cutting concepts. I'm going to assume it's you and a partner. So what I would ask is that you both read pages 1 through 3 and just skim the bolded parts of those. Skim pages 11 through 12, and then each of you just pick one cross-cutting concept, maybe one that you're not so sure about. Maybe it's stability and change or something like that that you just want to know a little bit more about, and just read that section. We're going to be sticking on page 2 in your handbook. So again, in page 2 on the final column there, just jot down anything that you learned about one or maybe a couple of the cross-cutting concepts from the reading. So after you've had a chance to do the reading, let's just debrief a couple of things. I wanted to go over a couple of highlights from the front matter and then the back section of that Appendix G on the cross-cutting concepts. There are a couple of the guiding principles in the first 3 pages that I wanted to highlight, and again, they're all very important, but there were just a couple I wanted to talk about. One is this idea that the cross-cutting concepts can help students better understand core ideas in science and engineering. That's really one of the key things about the cross-cutting concepts, that they can be like these clotheslines or touchstones that just help kids organize and make sense of the science that they're learning. Another one of the guiding principles was that the cross-cutting concepts can provide a common vocabulary for science and engineering. So not only the science and engineering practices, but having the cross-cutting concepts be things that kids are thinking about every year from kindergarten all the way up to the time they graduate. That's just going to be good common language for them to think about as they're learning their science and engineering. And another one to highlight is this idea that the cross-cutting concepts should not be assessed separately from practices or core ideas. So in other words, you don't need to create a little mini unit on patterns or cause and effect. You would be using those cross-cutting concepts in the content or the disciplinary core ideas that you would already be teaching, right? You don't need to do a separate unit of instruction. In fact, that's exactly what the next gen science standards are trying to get away from the separation of the practices and cross-cutting concepts. We want those 3 things to be integrated. In the back section, there's an interesting way that they reorganize the cross-cutting concepts, and I really like this. So on pages 11 to 12, they put this together. They say, what if we put the cross-cutting concepts into 3 categories? So category 1 is patterns, and the cross-cutting concept in that would be patterns. The second category is causality, where they put cause and effect and structure and function. And the idea here is that structure and function is really just kind of a subset of cause and effect. It's the idea that a structure causes or creates a certain function. So it's basically like cause and effect. And then the third category is systems. So the idea that the other 4 cross-cutting concepts, systems, scale, proportion, quantity, energy, and matter, and stability and change, those are actually all systems ideas. So patterns, causality, and systems become these bigger buckets for the cross-cutting concepts, which to me, it makes sense, and I like that organization. We're going to do one more activity to deepen our understanding of the cross-cutting concepts, and we're going to watch a video, and this isn't a video of students learning about the cross-cutting concepts. This is a video of some teachers in some professional development learning about the cross-cutting concepts. And the phenomena that they're thinking about is, and you can see in the screenshot here, they're making flags. So they had some dowels and some fabric and tape, and they made flags. And the question is, why does a flag wave in the wind? And at first, when you hear that, it seems like a simple question. It's like, well, duh. But then when you really try to explain it, it's like, oh yeah, why does a flag wave in the wind? So that's the question that they've been asked, and they're using the cross-cutting concepts to help them answer that question. So as you're watching the video, we're finally going to move away from page 2, which we've been working on for most of the session. And on page 3, I put some different areas for you to jot down, some notes about the video. But the main thing to think about is, how are the teachers using the cross-cutting concepts? And then there are really lots of great quotes and ideas that are shared in the video. So any of those that resonate with you, please feel free to capture them. So you've just finished watching the video of the teachers thinking about the cross-cutting concepts, and I just wanted to highlight a couple things that I think are important. There's lots of important things in that video. But towards the beginning, they talk about that the cross-cutting concepts are for students, right? They're not for us as teachers, they're for students, and they help them make sense of the science and engineering that they're learning. I think that's really important to remember. Another line in the video, they talk about that the cross-cutting concepts should be familiar touchstones. I think that's a great way to think of them, that it's just these ideas that we come back to. I was working with some fourth grade teachers recently, and a fourth grade teacher said towards the end of a session very similar to this, said, you know, when we teach literacy, we teach kids, when they're looking at a piece of narrative text, a story, to look at theme, and to think about characters and the plot and the setting. And this teacher said, to me, the cross-cutting concepts are just like that, but they're for science. These are ideas or concepts that you can use to explain any phenomena or to help you solve a problem. And there was something that was so helpful about that, right? That there's just kind of a universality about the cross-cutting concepts and how they might help kids. Another thing is to be intentional about the cross-cutting concepts. You know, a lot of times we'll say that, oh, these are kind of in what I'm already doing, but we need to be intentional about helping the kids see how those cross-cutting concepts are there. And then the last bullet point here, cross-cutting concepts help students make connections between domains of science and engineering and even outside of those domains, right? So that when kids are learning about something, it's just going to help them to apply those ideas to other areas in their lives. One point that I also wanted to make that I don't think we talked about with the hand bubblers is the idea that we don't need to feel like we should be asking about all 7 cross-cutting concepts all the time. We want to pick the concepts that really fit whatever it is that we're learning about. So for example, if we have a unit and we're learning about cells, we don't need to try to direct kids to all 7 cross-cutting concepts, but we do probably want to direct them to systems, to structure and function, and to energy and matter, because those 3 cross-cutting concepts are going to help them make sense of the learning they're doing about cells. Okay? So we are almost to the end of this module. Let's take a couple minutes to go over some take-home messages to kind of summarize what we were hoping to learn about the cross-cutting concepts. And the first is that the cross-cutting concepts are really helpful for students in making sense of all 4 domains of science. And by that, I mean life science, earth space science, physical science, and engineering technology. The cross-cutting concepts can really help kids to see some of the big ideas within those 4 domains. Another take-home message is that the cross-cutting concepts need to be pulled into the foreground for students. So a lot of times as teachers, we might see, for example, that systems is a really important part of something that we're learning, but unless we pull that into the foreground for students, they might not see that. Don't try to teach too many cross-cutting concepts at once, and be intentional. So in other words, sometimes when we first start to tinker with cross-cutting concepts, you're going to find lots of connections to cross-cutting concepts. And you're going to want to be very judicious in that. Just maybe pick 1, possibly 2 at the most, just to really be focused on a couple cross-cutting concepts. Cross-cutting concepts should not be taught in isolation, and by that I mean you don't want to just be doing a little mini unit on cause and effect or structure and function. You would actually teach those ideas right as you're teaching the unit that's on those disciplinary core ideas. And then just leaving us with a question, where might we intentionally start to highlight a cross-cutting concept in something that we're already teaching? So regardless of if you're doing a unit on cells at middle school, for example, you might want to focus on structure and function, or systems, or energy and matter. There might be a few cross-cutting concepts that you could think about highlighting over the course of that unit. So we are approaching the finish line here. Just one last thing to ask you to do, and that is that we would like you to take some time to reflect either on page 4 of your handbook, or if your district has asked you to use the Google form to actually type in your feedback there, and kind of have our same basic 3 questions. What's one thing you learned today about the cross-cutting concepts that you're excited about? What is one shift that you're going to make to be more explicit with students about the cross-cutting concepts? And then what's one thing that you still want to learn or to know about the cross-cutting concepts? Thank you so much for attending this online session and taking time out of your day to do that. Hopefully you feel like you learned a little bit about those 7 cross-cutting concepts and have some ideas of how you might start to use them intentionally with your students. Please be on the lookout for the next session of this online series, which will be NGSS 101 Part 4, Engineering Design in the Next Generation Science Standards. Thanks.